a lesson on Monday, and then Tuesday, Wednesday, Thursday are pretests. So after Tuesday, Wednesday, and Thursday, no, that's because I really didn't notice, but what the heck?
Yeah, it's fine.
Did you lose it when you were cleaning your desk?
No.
Your desk.
You did not clean your desk.
I should come in here when I
Yeah, like when they first helped me, like, do this, you want enough work, giving you it.
Like, yeah, 59, 3 minutes earlier than usual or something. Is it fine? Yeah. I hate spirit getting away, getting work done.
You're not even
You don't gain any
ready.
spirit going in there. You clown around for a little while.
3 minutes. I have spirit in my tutu.
It's great. I don't think we need a pep rally, and I don't think we need a week to declare spirit.
How come you're not wearing our school color? It's still the school.
No, I hate Spirit Week. I don't think about it. I really don't. I don't think good or bad. Can you get lights, please? It is what it is. All I ever come back to in my mind is that I promise you, in June, you're going to say, I want one more day to review. Okay. So I want that day. I want that. I don't want to lose the day. It's as simple as that. So, but they do the best they can given the situation, because we at least do get to only lose a few minutes of each class rather than lose an entire class. So, I have to remember, the next 2 years, I think I'm going to get sick on Spirit Day.
Whole week is spirit.
Why?
So I don't have to come to school. That way I don't have to be here and I don't have to deal with it.
You had that one extra day, but you weren't there.
Yeah, I know. Well, this way I don't waste my extra day on the day that the extra day is being wasted. Okay, so we look at this guy, and the first thing we want to do is combine like terms. So I'm going to minus a quarter x. And I hope that the people who worked with the calculators this time with fractions realized whatever it was that you were doing wrong. In the beginning, the first few kids who handed in their quizzes all had the same answer, like 160 over 3, and I couldn't figure out what they were doing wrong. I actually did it on my scientific calculator 3 times to make sure I didn't make a mistake. Then I borrowed Mary's calculator, and I did it on Mary's calculator to make sure I wasn't making a mistake. And then finally I said, they're doing something wrong, and I can't see what it is they're doing wrong. So then you talked about it, and you said that you found out what you were doing wrong? Everybody who got 160 over 3, you all realized what you did? Okay. Now, 7/8 minus 1/4 is 5/8. And then, I'm just in the interest of saving space, I'm going to add 4 2/3. I'm going to add 2/3 here. So I'm going to get equals 4 2/3. Okay, and then I now need to divide both sides by 5/8. Now, years ago, this was a much more challenging question than it is now because of the calculators. So Mary asked, how do you put a mixed number into the calculator? And it worked, right? I would do it this way. 4 plus 2 divided by 3, and that's 4 2/3. Okay? And then I would do divided by 5 divided by 8, making sure that's in a parenthesis. And when you did that, what did it work out to?
7.6 repeating.
Well, do math, enter, enter.
No, it's not.
It was a 7.6 repeating?
Yeah. No, because there's a 7 at the end.
Yeah, but that's the calculator rounding off.
Oh.
So that would come out to be 7 2/3.
I didn't know that. How did you get it?
Yeah, absolutely. Listen, guys, if a problem starts off in fractions, we're going to want the answer in fractions. So at the end, it's always math, enter, enter to do that.
It gives you like I mean,
Oh, the mixed number,
not a mixed number.
improper.
So
But
yeah.
then you can convert it back in.
So hard it goes.
Oh, I know, it's brutal. Yes.
Would it be better as a mixed number or if
Oh, by the way, yeah, typically, if you had written this, 23 over 3, you would get full credit. You just need to be able to go back and forth between the forms, because most often this would be a multiple choice. And then you want to make sure that you can see it equivalent in each. Okay, number 3, I don't know what happened to number 2, but apparently it went bye-bye. And this absolutely positively sums up yesterday's lesson to a higher degree, because this is almost as hard as it gets. an area diagram, you see, when we multiply, Flipper, when we multiply, what we're literally doing is finding area, like length times width is area. So when we multiply, we get area, and the length of this particular rectangle is 2x squared minus 5x plus 3, and the width is apparently x minus 4. So area really sets itself up to the box method. It's a great way to think of using the box method. So x times 2x squared is 2x cubed. X times negative 5x is minus 5x squared. X times 3 is 3x. Negative 4 times 2x squared is negative 8x squared. Negative 4 times negative 5x is positive 20x. And negative 4 times positive 3 is negative 12. Now, we mentioned yesterday the Fuji peanut, not named after the current Fuji family, but a former Fuji family. And you can always add on the peanuts, which amounts to the diagonals. So the 2x cubed is all by itself. This is standard polynomial order. Negative 5x squareds and negative 8x squareds are negative 13x squareds. 3x's and 20x's make a positive 23x. And then a minus 12. Okay? And that's the correct answer. And the big thing I want to note about this particular one is it's being done as an area diagram. It's a picture of the rectangle. Yes? Oh, I don't mean to be trite here, but if I get this understanding across to you, you're going to be okay. If I have 2 eyeballs with red paint under them, and I have 2 more eyeballs with red paint under them, do I get 4 eyeballs squared? No. In other words, whenever you add or subtract anything on the face of the earth, be it eyeballs with red paint, bows, textbooks, dogs, cats, I always get back the same thing I started with. So I'm saying I have negative 5 of these things called x squareds, and I have another negative 8 of those things called x squareds. Well, altogether I have negative 13x squareds. I do not have negative 13x to the fourths. The only time exponents change, if I did a question like this, times x squared, that would be 20x to the fourth, because I'm multiplying. Adding, it always stays the same. Adding and subtracting, okay? You have a very blank look on your face. You're okay with this? Or do you just disagree with me? All right? At its simplest, most elemental form, it's like saying this. Ready? If we have a square and each of the sides of the square is 5 inches, what's the perimeter of that square? What is the perimeter of this square? Guys, what's the perimeter of this square? 20 inches. It's not 20 inches to the fourth, is it? No, it's 20 inches, because when I add, it stays inches all the way around. Okay? All right. So I think it's very important. I want to come back to the point I made before about the fact that this was an area diagram. Area diagrams really set themselves up or lend themselves to a way of doing it with the box method and the Fuji peanut. But not everybody always wants to draw a box every time you want to multiply 2 polynomials. So we need to be able to do it another way. And I call this double distribute. So we're going to go step by step with this. Ready? I want you to distribute the first one, distribute the second one, leave the answers there. Should be very simple for everybody.
What did you do? It's the same thing.
Okay. Now, if I do my distributing here, on the first one, I'm going to get x squared plus 3x. And on the second one, I'm going to get 5x plus 15. Agree?
Yeah.
Go ahead.
It's 2x. It's the same as x squared.
No. 2x and x squared are very different things.
But it would equal the same.
No, it would not. Sure, let's take x is 5. What's 2x?
10.
And what's x squared?
Oh.
Okay. Here we go back to addition and multiplication differences. Ready? If I have 1x and I add another x, what do I have altogether? 2 x's. If I have an x and I times by another x, think of it as adding exponents, then I get x squared. Okay? So another variation off of the Francesca question. Now, the next question I put here, so the first one was x times x plus 3, and the next one was 5 times x plus 3. Now I put x plus 5 times x plus 3, and what you'll notice is I have that and that. So if I'm going to add this times this, what I'm literally going to get is the following. I'm going to get this product and add them up. And let me show you how we do this. We do a little thing. Now, some high school people call it FOIL. In fact, most of the people in the country call it FOIL. I hate FOIL. I hate the name FOIL because it makes it sound like a gimmick and it makes it sound like a trick. FOIL stands for first, outers, inners, lasts. Ready? First, outers, inners, lasts. That's what FOIL stands for. To me, it sounds like a gimmick and it sounds like a trick. And mathematics is beautiful, it's deep, it's profound. It's not gimmicks and tricks. So, I like to call this what it really is. Double distribute. I'm going to cover up the 5, and I'm just going to distribute the x. And that gives me the x squared plus 3x. In other words, the first part of the problem. Then once I distribute the x, I'm going to cover it up, and I'm going to distribute the 5, which gives me the 5x plus 15. Now, in the box method, we always got the future peanut, right? When we double distribute, these guys will always be combinable. So it's x squared plus 8x plus 15. And what we get is that if you multiply two binomials, almost all the time, not 100% of the time, but almost all the time, you're going to get a trinomial. 3 parts to your answer. Okay? So you try the next one, 2x minus 7 times x plus 9. Do the 2x, distribute it to both of them. Do the negative 7. Make sure you use a negative 7 there. And do that to both of them. You could, and it would work out the same. It'd just be kind of weird. I never did it backwards, per se. I think if you did it, I think all you would do is mix the terms in the middle up. I think you would just reverse them. Okay, another 20 seconds or so. You combine like terms in the middle. Yeah. Okay. All right, ready? 2x times x. Ready? Because we're going to do that first. Cover up the negative 7. 2x times x is 2x squared. Then I'm going to do 2x times 9, which is 18x. Then I'm going to do negative 7 times x, which is minus 7x. And then I'm going to do negative 7 times 9, which is negative 63. What's that? What's the one last step we need to do? Go ahead, Sammy.
Add the 18x and negative 7.
Right, combine like terms in the middle. Very good. So I get 2x squared plus 11x minus 63. Okay? Now, question, how many people got it right? Now, if you got it wrong, do you see where you went wrong?
Yeah.
Okay, that's the key thing, because now we do another one, and I think you'll be okay. Try the next one, guys. that all about?
They're getting cold.
Oh, okay, that was very kind of you then. Ready? 4n, cover up the negative 1. 4n times 3n is, 12n squared, very good. 4n times negative 7 is negative 28n. Then I cover up the 4n. I distribute the negative 1. Negative 1 times 3n is minus 3n. Negative 1 times negative 7 is plus 7. What do I always do when I double distribute?
Oh my God.
Guys, what do I always do now?
You combine.
Combine like terms in the middle. 12n squared minus 31n plus 7. We good?
I don't know why, but I added this.
And you know what? That's a very common mistake, and you got to make it a couple times until you don't do it anymore. So I don't want you to think that you can only double distribute. You can also triple distribute. So this goes back to the do it question. Do what you think you should do on this one. Go ahead. I don't even want to show it to you. I think you can figure it out without me. I would just do the x squareds first, then the negative 5x's, then the 2's. So we're triple distributing on this one. Question? Three x cubed. Yes, because I'm multiplying. You said the magic word. You said x squared times 3x. Then you add the exponents. If you had said x squared plus 3x, you couldn't do it because the exponents are different. Okay? Make sense? You look like a Christmas present. Okay, we're running a little out of time, so let's work it together. Ready? I'll do the x squared first. Some people like to draw the distribute marks. X squared times 3x is 3x to the third. And then x squared times negative 8 is negative 8x squared. So far, so good?
No.
No. Not a good sign. Now let's do the negative 5x times 3x. What do I get?
You get negative 15x.
No, you're multiplying. Negative 15x squared, right? Multiply coefficients, add exponents. And then it's going to be plus 40x.
Wait.
Go ahead. Let me go back. Ready? Watch. 5x times 3x is negative 15x squared. Negative 5x. Negative 5x times negative 8 is plus 40x. Now, I do the 2. What's 2 times 3x? 6x. And what's 2 times negative 8? Negative 16. And then the last step, just if you notice, now I'm going to have my x squareds together, and I'm going to have my x's together. So I get 3x to the third minus 23x squared plus 46x minus
Just stop the first part.
Wait, 3x to the third.
Okay?
You got it right?
Okay, you know you will see this multiple times between now and the test. So if you're almost completely understanding it, I suspect that by Tuesday you should completely understand it. Hey, does anybody here need a makeup test at lunch? How many makeup tests do I need? I need 1, 2, 3 makeup tests at lunch? Okay. I'm hoping by Monday or Tuesday to give you all your makeup tests back. So, I'll see how that goes. Hasta la vista, bye con Dios, toodaloo, ta-ta, arrivederci, smile a lot. Ciao, arrivederci. Hey, how's the munchies? Come here, I need help. I need the biggest amount of help in the world. I'm eating way too many cookies lately. And I just can't have this sitting and talking to me, telling me constantly to eat me. So, I need help. You be all right with that? Gavin, good to see you, buddy. See you later.
Flores to the main office. Stephen Badamo. Ariana Campitello. Raquel Flores to the main office, please.
All right, so you're gonna hang here for a minute. I'm just gonna go make, oh, never mind. I gotta let me. All right. All right, let's go. Come on, come on. Hey, what's going on, buddy?
Good morning, South Ocean Middle School. Today is Thursday, it's Friday, October 23rd. It is the day B.
Chin hut!
Please rise.
That was my last one. Hey.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Play ball.
Thank you. Please be seated. All right, happy Spirit Week. Today is Pep Rally Day. We do have an abbreviated schedule today. Each period is shortened by a bit. And we have our Pep Rally at the end of the day. All students at the end of 7th period should get all of their belongings that they need to bring home today and bring it with them to 8th period. You will not have time at the end of 8th period